You've probably heard that ancient humans only lived for 20 or 30 years. It sounds simple, but it creates a strange picture. A human being reaches adulthood, gets a few years of life, and then somehow dies of old age at 30. But that's not what the evidence tells us. A person living 30,000 years ago didn't necessarily die at 30. So where did that number come from? And if ancient humans could survive childhood, disease, injuries, hunger, and everything else the ancient world could throw at them, how long could they actually live? To answer that, we first need to understand something surprisingly important. What does it mean to live to 30? Imagine a group of 10 newborns. 5 die during childhood. The other 5 survive and eventually reach 60. If you simply average all 10 lives together, the result is nowhere near 60. The deaths of those 5 children pull the average dramatically downward. That is the basic problem with hearing a number like 30 years, and imagining that 30 was the normal age of death. Life expectancy at birth is an average based on the mortality pattern of an entire population. It is not a prediction that every individual will die at that age, and childhood mattered enormously. For much of human history, dying young was common. Estimates suggest that around half of newborns in many historical populations did not survive to the end of childhood or adolescence. That changes the picture completely, because there are really 2 stories happening at the same time. One is the story of people who died very young. The other is the story of the people who survived, and those survivors are the people we need to follow, because once someone had already survived childhood, their chances of reaching older adulthood were very different from those of a newborn. Studies of contemporary hunter-gatherer and small-scale subsistence populations are especially useful here, not because they are frozen versions of prehistoric humans, but because they give researchers real populations living without many features of modern industrial society. One major cross-cultural study found that substantial post-reproductive longevity is not simply a modern invention. Its analysis of hunter-gatherer and horticultural populations found mortality patterns consistent with people continuing to survive well into later adulthood. So already, the famous 30 years story is beginning to fall apart. But that raises a much better question. If 30 wasn't simply the age when ancient people died, how old were the people who did survive? This is where the investigation gets difficult. Ancient people didn't carry birth certificates. There were no passports, no hospital records, no one writing down, born in spring, died at 63. Instead, archaeologists are often left with bones and teeth, and those bones contain clues. During childhood and adolescence, the skeleton changes in relatively predictable ways. Teeth erupt, bones grow, growth plates fuse. These changes can help researchers estimate age, but once someone reaches adulthood, the problem becomes much harder. Researchers start looking at things like changes in joints, teeth, bone surfaces, and other age-related features. The problem? People don't all age at exactly the same speed. 2 people of the same chronological age can have very different skeletons, and the older the person, the wider the uncertainty can become. Research on archaeological skeletal remains emphasizes that adult age estimation is an estimate, not a precise birthday, and older individuals are particularly difficult to date accurately. Using multiple indicators can improve confidence, but there is no single technique that can tell us an ancient person's exact age. So when an archaeologist says, "This individual was probably between 50 and 60, that doesn't mean the skeleton came with a hidden label saying 57. It means several pieces of biological evidence point toward that range. And that distinction matters, because when we investigate ancient lifespan, we have to resist the temptation to make the evidence more precise than it really is. Now imagine looking at an ancient burial ground. There are children, teenagers, young adults, and then, among them, individuals whose skeletons show decades of accumulated wear. Some have severe arthritis, some have old fractures that healed, some have heavily worn teeth, some show diseases or injuries that they clearly survived for years. These remains are important because they prove something very simple. Ancient populations contained old people. Not necessarily lots of them, not necessarily as many as we see today, but they existed. And this makes sense when we look at mortality itself. Ancient people faced an enormous number of hazards: infectious disease, serious injuries, violence, food shortages, childbirth complications, parasites, extreme weather, and accidents that modern people might survive with a trip to an emergency room. There was no guarantee that a wound would heal. No antibiotics waiting if bacteria invaded it. No modern surgery if something went badly wrong. And no intensive care unit if the body began to fail. So the ancient world was not a place where everyone casually lived into old age. Far from it. The important point is that early death and old age could exist in the same population. Many people could die young, and a smaller group could survive much longer. That is the part the famous 20 to 30 year number hides. Think about a doorway. Every person in a population begins on one side. But along the way, people disappear. Some die as infants, others during childhood, others during adolescence or early adulthood. Some are killed by accidents, some by disease, some by violence. Some simply don't survive a period of famine or environmental stress. By the time a person reaches 40 or 50, they have already passed through many of those hazards. They are not an ordinary newborn anymore. They are a survivor of everything that came before. This is why looking only at life expectancy at birth can create such a misleading mental image. A population could have a low life expectancy at birth while still containing people who reached advanced ages. And this isn't just theoretical. The cross-cultural hunter-gatherer research by Gurven and Kaplan found substantial adult longevity and argued that post-reproductive survival is a robust feature of human life, not something that appeared only after modern medicine. That doesn't mean prehistoric people routinely lived to modern ages. It means something more interesting. Old age itself was not invented by civilization. Now the other side of the story. If the human body was capable of surviving into later adulthood, why were ancient populations still so heavily affected by early death? Because the environment was brutally efficient at finding weak points. Consider infection. Today, an infection can mean a doctor's appointment and a prescription. For most of human history, there was no such safety net. Then there was childbirth. A dangerous delivery could become fatal to both mother and child. Then injuries. A broken bone wasn't just painful. It could prevent someone from hunting, gathering, traveling, or protecting themselves. And then there was food. A modern person can open a cupboard when the hunt fails. An ancient community couldn't. A failed season could become a serious nutritional crisis. These hazards don't necessarily make the human body age faster. They simply create more opportunities to die before aging becomes the main problem. That distinction is crucial. Now compare that ancient world with the modern one. The human body didn't suddenly receive a software update. Humans didn't suddenly evolve a completely different aging system. Instead, the world around us changed. Clean drinking water reduced exposure to many infectious diseases. Sanitation separated human waste from drinking water. Vaccines prevented devastating infections before they could strike. Antibiotics made many bacterial infections treatable. Improved nutrition strengthened survival. Safer childbirth protected mothers and newborns. Surgery made previously catastrophic injuries survivable. Emergency medicine gave critically injured people another chance, and better housing reduced exposure to some environmental dangers. The result was enormous. Around 1900, global life expectancy at birth was about 32 years. By 2023, it was about 73 years. That is an extraordinary transformation. And yes, reducing childhood mortality was a huge part of it. But it wasn't the whole story. Life expectancy has also increased at older ages. A person who has already reached adulthood today is also less likely to die at many ages than someone in the past. So modern medicine didn't simply stop babies from dying. It gradually pushed back many of the threats that could kill people throughout life. Now we reach a deeper question. If an ancient human somehow survived the dangers of childhood, avoided a fatal infection, survived serious injuries, found enough food, and reached old age, would their bodies suddenly behave differently from ours? There is no evidence that ancient Homo sapiens possessed a completely different basic aging system. They were human. Their bodies were built from the same fundamental biological machinery. Cells accumulated damage. Tissues changed. Bones and joints deteriorated. The immune system changed with age. Organs gradually lost resilience. In other words, ancient humans didn't escape aging. They simply had a much harder time reaching it. And that gives us an important way to think about ancient lifespan. Modern humans don't necessarily live dramatically longer because every human body was redesigned to last longer. We also live longer because far fewer things kill us before aging has the chance to become the main threat. There are ancient individuals who make this idea much more tangible. Take Neanderthals. Their lives were physically demanding. They suffered serious injuries, yet some individuals survived long enough to show substantial age-related degeneration. One of the best-known examples is Shanidar I, discovered in Shanidar Cave in Iraqi Kurdistan. His remains show multiple serious health problems, including major injuries and degenerative disease. Exactly how his injuries affected his life, and precisely how old he was, remain subjects of scientific interpretation. But the broader point is striking. He survived for years despite severe physical limitations, and that means somebody had to help him. Food had to reach him. He had to be protected. He had to remain part of a social group. Evidence of care in ancient human populations is important because it changes the image of prehistoric life. An old or disabled individual wasn't automatically useless. Human communities could support people who could no longer contribute in the same ways they once had. There is even evidence of sophisticated medical intervention far deeper in prehistory than many people would expect. A 31,000-year-old individual from Borneo, for example, shows evidence of a surgically amputated lower leg, with survival for years afterward. That's not evidence that prehistoric medicine resembled a modern hospital. It doesn't. But it does show that ancient humans could understand injury, respond to it, and care for someone afterward. And that brings us back to the question of age. If ancient people could survive severe injuries and live into older adulthood, where exactly was the biological boundary? Here we need to be careful. There is no reliable fossil that lets us say, this was definitely the oldest human who ever lived. The fossil record is far too incomplete. Most humans who ever lived left no skeleton behind, and even when a skeleton survives, determining its age can be difficult. So we should be suspicious of spectacular claims. Ancient legends sometimes describe people living for extraordinary lengths of time, but legend is not the same thing as biological evidence. Written records are also complicated. Birth registration was often poor or non-existent. People could genuinely misremember their age. And claims of extreme longevity require unusually strong documentation. That's why modern longevity researchers demand extensive records when verifying extraordinary ages. For ancient populations, the evidence is much weaker. What we can say with confidence is more modest. Humans have repeatedly reached advanced adulthood long before modern hospitals existed. The exact frequency is much harder to establish, and that uncertainty is actually part of the story. Now the question becomes more interesting. If ancient humans could reach old age, and modern humans can reach 80, 90, or sometimes more than 100. Did evolution simply keep extending our lifespan? Not exactly. Human longevity is the result of biology interacting with environment, behavior, culture, and mortality risk. The human capacity for substantial adult longevity is ancient. Gurven and Kaplan's analysis of hunter-gatherer and horticultural populations even found mortality patterns consistent with an adaptive human lifespan extending well into the late 60s and 70s. That does not mean ancient hunter-gatherers routinely lived to 70. It means their analysis suggests the human life history pattern includes substantial potential for survival into older adulthood, and modern society has dramatically increased the number of people who actually reach those ages. That distinction is everything. Now finally we can ask the question we deliberately avoided at the beginning, not, how long did ancient humans live? We've answered why that question is complicated, but how long can the human body itself keep going? This is where we enter the strange territory of extreme longevity. The longest fully authenticated human lifespan is 122 years and 164 days, achieved by Jean Calment of France, who died in 1997. But notice the wording, longest verified lifespan. That is not the same thing as saying absolute biological limit. Scientists continue to debate how sharply human lifespan is constrained and whether there is a hard maximum. As people age, cells accumulate damage. Regeneration becomes less reliable. The immune system changes, blood vessels and organs become more vulnerable. The body's ability to repair itself gradually declines. Eventually, multiple systems become less resilient, but there is no scientific stopwatch inside the human body that says, at 122, everything stops. 122 is the longest verified observation. It isn't proof that another human could never live longer, and this distinction separates what we have observed from what biology might theoretically permit. Now we can finally return to the question we started with. Did ancient humans only live 20 or 30 years? No, not in the way that statement suggests. Those numbers can describe life expectancy at birth in populations where early mortality was extremely high. They do not mean that a human who reached adulthood was destined to die at 30. Ancient populations contained children who died very young. They contain young adults who died from hazards that modern medicine can often prevent or treat. And they also contain survivors who reached later adulthood. Some became old. Some lived long enough for their bones to record decades of physical history. And some survived despite injuries and disabilities that would have been extraordinarily difficult to manage without community support. What changed in the modern world was not simply that humans suddenly became capable of aging. We became much better at surviving long enough to experience it. Child mortality fell, infections became more manageable, food became more reliable, water became safer, childbirth became safer, injuries became more survivable, and medicine pushed many causes of premature death farther away. The global transformation is enormous. Average life expectancy at birth rose from roughly 32 years in 1900 to more than 73 years by 2023. But behind that number is something even more remarkable. For thousands of generations, humans were already capable of becoming old. The difference is that far fewer people made it there. Maybe humanity didn't learn how to make the human body live twice as long. Maybe we learned something more fundamental: how to stop losing people before they reached old age. And that leaves us with one final question. If the human body has always possessed this capacity for longevity, how far can it really go?